students, welcome to today's topic. Today we are going to discuss about ortho effect. So what is ortho effect? From the name only you can say this is a effect which is definitely related to the ortho substituent. So ortho effect means something definitely related to ortho substituent. It's of course organic topic, and in JEE NEET everywhere this topic is important. So let's go to direct to the topic. Now, before we discuss the topic, we have to discuss some basic things. So what are the basic things? The basic things is this. The we know that there are aromatic carboxylic acid. Carboxylic acid means there are some CO2H group is there, and um, there is a benzene ring. Then this should be aromatic acid. Benzene ring means aromatic, and if there is some acid group is there, that will be aromatic acid. Now we saw that if in the aromatic acids, if we put some substituent in aromatic acids, if we put some substituents means, as you can see in the screen here, there is Cl substituent, this is para, this is chlorine, this is ortho, and this is meta, and this is ortho. Similarly here para, meta, ortho, but the group changes to CH3. So there are some substituent. They all the same substituent we are putting in the direction of we all are putting in three position: para, ortho, and meta. Both in the cases Cl and CH3. Now let's check about their acidity. How we check acidity? For acidity, we usually consider the peak AA value. We are not discussing much about that here. So pKa is a parameter of acidity. Lower is the pKa, higher will be the acidity. Now let's check the acidity of the first three molecules. Now first is the para, second is meta, and third is ortho. We can see that going from para to meta to ortho, the acidity increases. Lower is the pKa value, higher is the acidity. So here the acidity is lower, so definitely pKa is lower, so acidity is higher. Similarly, for the second case also, you can see the acidity order is same. For the ortho, the acidity is somewhat more high, but this trend of acidity, that the ortho have more acidity, is independent of the type of substituent, because chlorine is electron withdrawing and CH3 is electron donating. In both cases we can see that the acidity of ortho is higher in both cases. So definitely there is some reason with the ortho, and this thing gives us the knowledge of the effect, that is ortho effect. So ortho effect actually comes from the exceptional higher acidity for the aromatic acids. So we have seen the result or the consequence. Now we will discuss about what is the ortho effect and what is the reason for the ortho effect. So without wasting time, let's go. So what is ortho effect? Ortho effect, we can say ortho effect, as I already said, that ortho substituted benzoic acid. This benzene CO2H, that is the benzoic acid. Now if there is ortho substituent, the acidity increases. And they said no matter whether the substituent is electron releasing or electron withdrawing, no matter means CH3 is electron releasing, chlorine is electron withdrawing. In both cases, the acidity for ortho is very high. So definitely there should be some reason regarding the ortho. So this is the thing. This is the definition of ortho effect. Now let's go to the other thing. So ortho effect is what? So anything we have an acid, COH group, and G. G our is the substituent. So substituent is our G. Now let's think that what happens. We have ortho substituent, so acidity will be increased. It will not depend on type of the substituent. Electron releasing, electron withdrawing, both will give you the same type of acidity. Acidity for ortho will be increased. Now, definitely everything happens for reason. So, the reason, what is the reason here? Here the reason will be both static and electronic. We will come to that. Other some factors are played, but there is a minimal effect. For now, we can think about only the static and electronic effect. Now, next is the one another effect is I said that small effect, that is the size of the substituent. Higher the substituent G, okay, substituent G, higher is the G, higher will be the acidity. So the bigger the G has a bigger size, higher will be the acidity. Because higher will be the ortho effect, higher will be the ortho effect, higher will be the acidity. Let's go to the next part. Next is the reason why the ortho effect plays into action. Now let's see about some compound. Here we have 2,6-dimethyl benzoic acid. 2,6-dimethyl benzoic acid we are having. So here what happens is that in this 2,6-dimethyl benzoic acid, both the ortho substitution are there, 2 position and 6 position. Both there is 1 substitute. What is the substituent here? Here the substituent is CH3. Now CH3 is a big group. So here this is a big group, this is a big group. So due to this big group, there is a repulsion creating between these H carbons, a hydrogen, CH3 group and the oxygens. So basically what is happening? Again I am repeating that we have 2 CH3 group at ortho position and we have the benzoic acid. Now already the acidic proton released. Acidic proton already released. Now there will be CO2 minus, formation of CO2 minus, carboxylate ion formation is there. Now what is going to happen there? Here the CO2 minus already formed and there is one CH3. So CH3 is opened like CHH. Here is also CHH. Now this H, they actually interact highly with the oxygen atom. So highly interaction means there will be a repulsion. They are very close together. These oxygen and hydrogen, they are very close together. As they are very close together, they repel each other. Now, due to the repulsion, before everything we know that benzene itself is a planar molecule. Now, due to planarity, all these substituents are in the same plane. Now, as there is steric crowding or steric effect is there, they are changing their position. This is before. Now this is moving to the 90-degree direction. So as they are moving to 90-degree direction, or you can say that this is our molecule, normal molecule is there. Now this is moving to this direction. Only the above CO2 minus group. So before that it was here and it is moving to the 90-degree direction. but all the others are same. Only the above part, others part is same. So what is happening here? Here we have this group change its position. Now, as they change their 90-degree position, they are far away from each other. So the static interaction lost. Static interaction lost. But what is happened here? Here now the benzene ring, the actual resonance occurred between this CO2 minus. Now, the benzene ring, the resonance occurred between only these two. No other things are participating in the resonance. That is why the structure become more stable. As the structure become more stable, the acidity will increase. So, as a summary, we can say the due to the ortho substituent, the CO2 minus group rotates 90-degree, and then the CO2 minus, the O minus, they get high stability. As there is high stability, no electronic or static repulsion, the conjugate base CO2 minus means what? Conjugate base, and conjugate base more stable means acid will be more stable. This is the reason for the more acidity of this ortho effect. And similarly, you can see the below picture. Here you can see that before it was in the same plane. Now it can move to the out of the plane, and out of the plane structure is more. This is a equilibrium, but equilibrium this alloy is more, the lower alloy is less. So, all over we can say due to static and electronic effect, if there is any substituent for benzoic acid at ortho position, the acidity will definitely increase. Whatever the substituent, acidity will increase. But the increase in acidity, amount of acidity increase will depend on the size of the substituent. Why size of the substituent? Because there is already repulsion. More there will be repulsion, more there will be the effect of ortho, because more repulsion, and the more will be stabilization of conjugate acid, and then more will be the acidities. This is all about the ortho effect. Thank you so much for watching the video.